Gastronomy mixes physics and chemistry to transform the texture and taste of food. The science of this gives many different cuisines a different taste, just as our everyday foods. The term molecular gastronomy was born in 1992 when an English teacher of cookery proposed a workshop in which professional cooks could learn about physics and chemistry of cooking. Molecular gastronomy research started in the kitchen, where chefs studied how food tastes and behave under different temperatures, pressure, and other scientific conditions. Molecular gastronomy seeks to investigate and explain the chemical reasons behind the transformation of ingredients, as well as the social, artistic, and technical components of culinary and gastronomic phenomena. Many modern chefs do not accept the term molecular gastronomy to describe their style of cooking and prefer other terms like modern cuisine, modernist cuisine, or experimental cuisine. Whatever they want to call it, there are endless possibilities of what you can do with molecular gastronomy. Molecular gastronomy experiments have resulted in new innovative dishes like hot gelatins, airs, full caviar, spherical ravioli, olive oil spirals, and crab ice cream. One of the chefs, Farhan Adira, from El Bulli restaurant, used algonites to create his system of spherification, which gels spheres that literally burst in your mouth. Another chef, Heston Blumenthal, from the Fat Duck restaurant, discovered the ability of fat to hold flavor and created a dish that had 3 flavors: basil, olive and onion, which each taste being preserved in sequence. The potential of molecular gastronomy is enormous, though. Some other chefs outside of Heston, which he's from Bray of the United Nations, there's Jose Andres from the District of Columbia in Washington, Seiji Mamamoto from Tokyo, Japan. They use molecular gastronomy. R.J. Cooper from Virginia, McLean, Virginia. And there's Paco Ranacero from Madrid, Spain. And I'll just go ahead and let my other classmates tell you more about molecular gastronomy further. And they also have recipes that they can share with you.
The next part of molecular gastronomy I'd like to talk about is actually called molecular mixology. I think we've all seen those chic bars on movies and on TV that have those crazy looking drinks that have fog coming out of them, the jello shots and everything else. Well, here's how they're made. There are many different types of molecular mixology. Just to highlight a few would be hot infusions, cocktail marshmallows, paper cocktails, cocktail gels, and of course layered cocktails. One that I think we're all most familiar with would have to be the cocktail gels, otherwise known as jello shots. Cocktail gels come in an extremely wide variety of different types. You have the regular ones that come in the plastic cups that we've all seen at parties, along with the fancy ones that you can see here in this slide. Next. Cocktail gels are basically a fancy form of saying jello shots. So is it a liquid, solid, or what is it? It's a gel. A gel is a thickened liquid that has been infused with long polymers and tiny colloids joined together by cross-linking. This cross-linked substance is also known as gelatin. Gelatin is a type of tough, flexible protein that is derived from animals. Like I said earlier, there's two parts of these Jell-O shots. The liquid part, which would be the booze part, your favorite alcoholic beverage, and the gelatin part. Gelatin comes in a powder form, which you would then mix with the desired alcohol. Once you've mixed these two products together, you would then heat the solution until it comes a pasty texture known as slurry. Once this slurry has become a consistent texture, then you know you've made it.
Flash freezing is a very commonly used process where food is frozen at extreme temperatures very fast, usually within a few hours of being picked or prepared. This is done in commercial uses to maintain the nutrients of the food, and it also helps keep it fresh and flavorful. It is used in the scientific community as well to preserve specimens very quickly. However, this technique can be used at home, although obviously not to the extent that the industry is able to do. By placing the food on a tray and letting it freeze overnight, you can achieve flash freezing at home. Flash freezing was originally developed by Clarence Birdseye as a way to preserve vegetables over the long winter. He also used it when transporting food around the country. He soon created what is known today as the frozen dinner, making millions of dollars in the process. This technique is commonly used in molecular gastronomy, although it was originally done with dry ice. But as liquid nitrogen has come into play, chefs are now starting to use this much more. They do this because liquid nitrogen allows the food to be frozen almost instantaneously. Chefs also use this for the viscosity, as it can get into the nooks and crannies of the food, allowing an even deeper freeze. The ability to maintain the food's texture is one of the main reasons why this technique is so widespread throughout the industry. Foods such as hamburgers and delicacies such as foie gras are some of the more common foods being cryogenically cooked, although ice cream is the most popular. Other unusual foods like frozen foam, however, are also becoming more used in the industry.
Effervescence is a chemical reaction that results in the release of gas and the formation of foam, fizz, or bubbles used to make pop rocks and sodas. In order to make popping sugar, the sugar mixture must be melted at about 300 degrees and then put into the presence of pressurized carbon dioxide at about 600 pounds per square inch. So after it's done cooling, the gas is trapped inside the sugar bits. When the sugar later melts in the mouth or is bitten into, the carbon dioxide is released, resulting in a popping sensation that is felt as you ate it. Fizzy sodas are made whenever pressurized carbon dioxide is mixed with the syrupy mixture that's the actual drink. An unopened can of soda is virtually bubble-free because the pressure inside the can keeps the carbon dioxide dissolved in the liquid. Sodas are kept refrigerated most of the time because the colder the drink is, the more fizzy it will be. When you crack open the can, finally, you release the pressure and allow the gas bubbles to wiggle free from the liquid and rise to the surface.
Sous vide, French for under vacuum, is a technique that involves food, most often meat or vegetables, being cooked in a sealed, airtight plastic bag submerged in a temperature-controlled water bath for an extended period of time, usually several hours, with 3 days being roughly the longest amount of time the most complex sous vide dish would need. Because of this, the resulting food is cooked evenly, with an equally tender inside and outside. However, sous vide cooking requires an almost mathematical level of precision in order to achieve perfect results every time. A sous vide steak would not be cooked according to rare or medium rare. It would be cooked at exactly 126 or 131 degrees Fahrenheit. As you can see in the left photo, ingredients used to add or enhance flavor are sealed in with the meat and/or vegetables, helping infuse the flavor slowly into the food. The vacuum packing process provides consistent pressure, which then can, when used with fruits or vegetables especially, compact the cells of the fruits or vegetables and concentrate their flavors. The finished dish is in the right photo, Baths with Vanilla Bean by Yannick Aleno of Le Marie in Paris. Clearly, the bass has shrunken down with the very slow cooking process and has become saturated with flavor. The graphic on the left shows various trials in creating the perfect soft-boiled egg using Sous Vide. In Sous Vide, cooking is truly a scientific process, complete with experimentation and math. The photos on the right compare Sous Vide cooked proteins to regular cooked proteins. The food on the left were cooked with Sous Vide, and the evenness of their cooking is very noticeable. Evidently, with portrayals on cooking TV shows, notably Top Chef, its use in some of the most buzzed-about restaurants worldwide, and even a feature in The Simpsons episode The Food Wife, molecular gastronomy brings the complex world of chemistry to the masses in a way more accessible and better tasting than hanging out in chemistry labs.